Myself, Dr. K. Vishwanath Alamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dindigul, Hyderabad, India. Today we are going to discuss about kinematic pairs and its classification. What is kinematic pair? The kinematic pair is simply a pair or is a joint. Is simply a pair of two links, or is simply a pair is a joint of two links having relative motion between them. That is kinematic pair. Generally, pair means two things. So here the things are elements. Elements are links. So in a slider crank mechanism, if we observe here in this figure, in a slider crank mechanism, the link 2 rotates about in relation to link 1 and constitutes a revolute or turning pair. This is a turning pair. Similarly, link 2 rotates or having a motion in relation to link 3 about a joint. This link 2 and 3, 2, 3 is a turning pair or revolute pair. And link 3 rotates having a link 3 having a motion relation to link 4. Now the link 4 is a slider. Link 4 is a slider. Which reciprocates in relation to link 1, and that's why the motion, the relative motion between the link 4 and link 1 is sliding. That's why link 4-1 is known as sliding pair. Now, in this mechanism, how many turning pairs are there, and how many sliding pairs are there? There are 1-2 relation. If you understand 1-2, 1-2 is one turning pair. 2-3 is second turning pair. 3-4 is another turning pair, third turning pair. And whereas 4-1, link 4 to link 1 is sliding pair. So in this mechanism, there are 3 turning pairs and 1 sliding pair. But this classification is based on the nature of relative motion. Now, again, what is kinematic pair? A kinematic pair is simply a pair is a joint. What is the pair again? A pair is a joint of two links having relative motion between each other. The relative motion can be a rotational, and it can be a translational, or it can be a combination of rotational and translational. Now, in this slider crank mechanism, why it came, the meaning itself, slider, there is one slider and one crank. The link 2 is a crank and link 4 is a slider. That's why it is a slider crank mechanism. Another manner, is this double slider mechanism, double slider single crank mechanism, or single slider double crank mechanism? No, it is a single slider single crank mechanism. Okay, if we will study in more detailed manner in this class that these kinematic pairs are various types are there based on the relative motion, based on the relationship between the two links. If the relationship between two links, if the nature of relation between two links is contact relationship, then based on there are two types are there. What are they? They are lower pairs and second one is higher pairs. If the nature of two links is mechanical constraint, again there are two types are there. That is open pair and another one is closed pair. And based on the nature of relative motion, there are 6 types are there. 6 types of kinematic pairs. Now, let us begin with based on the nature of contact, there are 2 types. Number 1, lower pair, and number 2, higher pair. Higher pair. Now, what is pair means 2. It is a joint of 2 links. Okay, it is a 2 links joint. That means binary joint. Now, if the contact between 2 links is either surface contact or area contact, then that pair is called as lower pair. So the contact surfaces of the 2 links are same, remains the same, it is similar. Suppose if you are clapping, there are 2 hands. If you clap it, the contact between this is considered according to kinematics considered as 1 link. The second hand is another link. The contact between 2 links, 2 hands is surface contact. How much link 1 having touch with link 2, the both remains the same or similar. There is no change at all. That's why it is known as lower pair. So when the people clapping, what type of motion it is having? The surface is contacting each other. Then it comes under lower pairs. Suppose if the contact between, that is surface contact or area contact. So where it will happen? This type of lower pairs. The examples of lower pairs are nut turning on a screw, shaft rotating in a bearing. Whatever bearing, it is a journal bearing. Next, all pairs of slider crank mechanism. And finally, universal joint. These are all comes under the category of lower pairs. Let us see. How can we call it as it as a lower pair? This nut turning on a screw is a lower pair. In this figure, these are examples of lower pairs. How the nut turning on a screw. You can understand here. Here inside the boundary, it is completely in touch. If you see here, the nut inside, whatever, it is completely contact, in touch with the bolt. The nut turning on a screw. We can see very clearly this type of relative motion, or it is the surface contact, then is known as the lower pairs. Next example, if you see in this figure, a shaft rotating in a bearing. Here it is also sliding. We can see there are different motions between different links, but all the motions, if you clearly observe, either surface contact, it is completely surface contact only among all the links. There is a relative motion of shaft with respect to the bearing, and here also shaft in touch with another hollow part, and this end, the shaft is another end of the shaft is rotating in another bearing. This is another contact. This is also another. 1, 2, 3 here, and one more. It is the surface contact completely, the sliding. Now, how many contacts are there? How many pairs are there? There are 4 pairs. All 4 pairs comes under the category of lower pairs. Okay, that's why this shaft rotating in a bearing is an example for lower pairs. Okay, next. This is another example to understand the concept of lower pairs. It is example of all pairs of slider crank mechanism. Yes, how many pairs are here? So this is a link 1 and link 2 is the crank, and it is link 3 is the connecting rod, and link 4 is the slider, and it is again link 1. The contact between link 1 2, there are 2 links, it is a pair. That contact is, yes, you can see here what type of contact it is. It is complete again surface contact, and link 2 and 3 is another pair. It is also same surface contact, and link 3 and 4 again surface contact. Link 4 and 1 is surface contact. That's why all pairs, how many pairs are here? There are 4 pairs are here. There are 4 pairs. In that, if we subclassify, 1 pair is sliding pair, and 3 pairs are turning pairs. So, whether it may be sliding pair or turning pair, but if you observe carefully, the contact between 2 links is surface contact. That's why it comes under the category of lower pairs. Okay. Now, very important is that all fixed links we have to consider as a single link. Here the link 1 I consider as a fixed link. It is fixed. And link 1 here also it is also fixed. But the part may be different. Here in the slider crank mechanism, it is a cylinder that is fixed. Here it is the fixed link 1. So all fixed links means, understand, it doesn't have any motion. It remains fixed. If more than 2, more than 3, more than 1, parts may be different, but it doesn't have any relative motion. It remains fixed part. Those fixed parts are considered as fixed links. In order to calculate the degree of freedom of mechanisms or in order to find out or in order to do analysis, kinematic analysis of any mechanism. It is very, very important concept. But parts are different. But we always do analysis in kinematics based on the link is under motion or not. If the link is under motion, then we consider separate link. If parts may be different, if the parts are different, but those parts doesn't have any motion, those parts we'll consider in kinematics as fixed links. Okay, next. This is another concept of slider crank mechanism. So here the input is the slider we are giving, how it is motion in relation to the crank. The slider and crank are having a relative motion in each other through the link of connecting rod. The crank is rotating in circular direction, in circular complete, and the slider is sliding, having reciprocatory motion. So this mechanism, where will it be used? It will be used where the requirement of considerations converting reciprocatory motion to circular motion or rotary motion, or converting rotary motion to reciprocatory motion. At that place, are we going to use this slider crank mechanism? This is an example for lower pace. The example is universal joint. How the universal joint comes under the category of lower pace? Yeah, if you see one of the shaft of the universal joint, and when it is rotating in another shaft, is the contact. The contact is surface contact. This is one end. Similarly here also, second surface contact. Okay, the contact is, that's why universal joint. And another joint is that another contact is eye. If you see the eye contact, there also it is in surface contact. That's why it comes under the category of lower pace category. Okay, thus these are the examples of lower pace. What are the examples are? Once again, recalculate. Number one, a nut rotation in a screw, nut turning on a screw. Second example is shaft rotating in a bearing. The third example is all pairs of slider crank mechanism. All pairs of slider crank mechanism. And final example is universal joint. These are the some or few examples mentioned to understand the concept of lower pace. To understand the concept of lower pace, some examples are shown here. You can think of different examples in day-to-day life. Suppose if you are sitting on a chair, the contact between the chair and your body is a surface contact. The contact between the person who is sitting, okay, is, if you understand, the chair, that is the surface contact. It is also another kind of category. It is the lower pace. If you are clapping that is the lower pace comes under. So if you are holding any rod, suppose I am holding a circular rod when you are traveling in a metro train, then what will happen? The contact between your hand to the point, the part of the train, then it comes under lower pace. So very carefully, if you think more, the coefficient of friction is high in the case of lower pace. Why? Because the contact surface, the contact area is higher in lower pace in comparison to higher pace. So what is higher pace? Let us see. So this is also another example of universal joint, how the rotation takes place of the motion between two links in relation to the I. I is the middle point, the mid shaft. This is input. If you consider, one is input shaft, another one is output. So it is having various motions. That's why these universal joints are highly useful in order to transfer motion from one link to another link. This is also another type of universal joint, how it will transfer the motion from one shaft to another shaft when you see in the different axes having angles. If you see here how the shaft is rotating, one way, this is another, this is another direction. So whenever we want to transfer the motion or transfer the torque with the different inclinations, with the different angles, this universal joint will be used without changing the magnitude of the torque. Now, coming to the category of higher pace. When a pair has a point or line contact between the links, it is known as higher pair. The contact surfaces of the two links are not similar. That means it is dissimilar. Now, when a pair has a point or line contact, suppose the point, ball point is there. This is the point marker. I am touching the surface of the pad. So this ball is in touch with the surface. This, when the ball is touching with the surface, it is the point contact. So it is a fixed link 1 and it is link 2. The relative motion may be rolling or translational, but the contact remains same. That contact is point contact or line contact. If it is the sphere, it is a point contact, and if it is the roller, then it is line contact. Suppose this link 2, this ball is rotating on the surface. What is the ball or wheel? When the wheel is rotating on the surface on the road, if the wheel is having, then what happening? Through various point contacts, it revolves, it rotates on the surface. So this pair, the pair means link 1 and link 2, is known as higher pair. What are the examples for higher pair? When a wheel rolling on a surface, cam and follower pair, tooth gears, ball and roller bearings. How this wheel rolling on a surface comes under the category of higher pair? Yes, you can see different types of wheels. Here the wheel, the contact between the road and the wheel is the point contact. No matter thousands of kilometers may travel, this wheel can move. But this wheel can be moved with a point contact of the surface and moves on. Now here you can see here, this is another type of wheel. So the contact between these two, road and is the line contact. Here in this category, it is the point contact. Here it is line contact. So if we consider the road as a fixed link and the wheel as a movable link, this fixed link, movable link, motion or pair is line contact or point contact. That's why it comes under the category of higher pairs. Alright. Now another example. Cam and roller follower pair. Very important. We will study in the further classes under the module 4 cam profiles. We have to draw the cam profiles at various motions of follower. This is the follower. This part is the follower and it is a cam. So the motion between cam and follower can become a various motions, that is simple harmonic motion, uniform, velocity motion, uniform, acceleration and retardation. In this figure, the follower is a roller follower. The contact, it is the cam. The contact between roller follower surface and the cam is point contact. On any surface of the cam, no matter, it can become any on the surface. If we consider the contact remains same, that is point contact. That's why this roller cam and roller follower pair comes under the category of higher pairs. Now it is roller follower. You can see here again the contact remains. But if we understand the contact of the roller to the cam by spring. So we'll study in the nature of mechanical constraint. Based on mechanical constraint of kinematic pairs, it comes under the category of unclosed pair or open pair. We'll study again. Open pair or unclosed pair. We will study in second classification of kinematic pairs. But based on the contact between the two links, consider it is link 1 and it is link 2. So the contact between two is point contact. That's why it comes under the category of higher pairs. Here, cam and another type of follower, that is knife edge follower. The follower at the end, the tip is in knife edge. So the contact between cam and knife edge follower is a point contact. It is a point contact. That's why it comes under the category of again higher pairs. Why I am explaining more in detail? Because it is very important question for mid exams or CAE 1, continuous internet evaluation 1 exams, and also for end semester examinations. So if we thoroughly observe or hear, see this video, no need to specially, prepare, pay attention to again for opening a textbook, not at all required. So that's why I am explaining in detail to make the students to understand better. So it's very, very important. So cam and knife edge follower pair also comes under the category of higher pairs. Now it is another type of follower. The follower at the end is having a flat face. That's why it is called cam and flat faced follower pair. But even though the face is flat, but it is in contact with circular surface, some curved surface. So that's why the contact between the cam and follower is what? Point contact. That's why it comes under the category of higher pairs. So, various types of followers we have studied. This is again flat faced follower. This is in this figure knife edge follower, cam and knife edge follower. It is cam and roller follower. Yes, cam and roller follower. So these are the three types of followers we'll study again under module 1. Under module 4, module 4, where we'll study how to draw the cam profiles at various followers. Okay, suppose if I consider the follower is roller follower, and how to draw the cam profile. And when one more condition is that if the follower is any one of these three motions, that is simple harmonic motion or uniform velocity motion, or it can be uniform acceleration or retardation motion, or it can be any two combinations. So here, what is any two combinations? When follower is rising, okay, when follower is rising up and down motion, but the cam is having, there are certain things are again. When cam is having certain motion and input, when it is rising up with simple harmonic motion, and there is constant arc is there, no constant radius of curvature is there. At that time, this follower doesn't have any motion. It dwells, remains dwelling. Okay, after that again it coming down, next rest of the angles. So this circle of motion, the motion of the cam is divided into different parts. Okay, in a simple manner, one is angle of rising. Certain angular portion, the follower will rise. That is called angle of rising or rise angle. Again at certain portion, at certain angle, theta 1, theta 2 and theta 3 suppose. At the theta 2, what will happen? This cam is having different angle, no? So at this portion, what will happen? It will rise. That's why angle of rise. And remaining portion will be there. It remains constant. There is, okay, the radius remains constant. That is called angle of dwell. Next, and remaining another portion, this is total 360 degree minus theta 1 minus theta 2 equal to theta 3. And angle theta 3 is angle of fall. Okay, that angle of fall can become either any one of simple harmonic or uniform velocity or uniform acceleration. So under these conditions, we have to draw the cam profile, the shape of the cam. What is the profile of the cam? That will be studied in detail in module 4. Okay. Now, Coming to another examples of higher pairs, the toothed gears. There are various types of gears are there. Now it is the spur gear. The spur gear looks like this in real field. This type of gear is called the teeth. The teeth are having, if you see the tooth, the shape of the tooth is like this. So it is having straight edges. There is no inclination. Then the same spur gear can contact with another spur gear. Then it is called spur gears. The contact between two spur gears, how it looks like that. Then it is called, again, if it is line contact or point contact, we will see it. Then it comes under the category of higher pairs. Here see, the teeth is having, this is a curved surface. And another teeth also having another curved surface. The contact between two curved surfaces is which contact? It is line or point? Yes, point contact. Then that type of pair is known as higher pairs. Now another category is called herringbone gear. This is herringbone gear. It is double helix and it is bevel gears having the angle is at different angles. Bevel gears perpendicular, normal too. And it is worm gears. You can see worm gears looks like that. It is inclination and is rack and pinion gear and it is internal gear. Now the motion between two spur gears. The motion between two spur gears is the contact. This contact is known as the point contact. It comes under the category of higher pairs. Then it is worm gears. Looks like this. The motion between it comes under the category of higher pairs. Okay. We'll study in more details. Now it is herringbone gear, double helical gear. Double helical gear contact will be again point contact only. Now it comes under the category of higher pairs. These are the different examples of bevel. This is bevel gears. So it is again higher pairs. Okay, this is rack and pinion gear. Also comes under the category of higher pairs. This is internal gears contact. How the internal gear is having contact between two teeth is again point contact. It is along the line, it becomes a line contact. But the two curved surfaces, if you see, is definitely a point contact. That's why it comes under the category of higher pairs. This is ball and roller bearings. You see the ball contact, inner surface touch is higher pairs. The roller, in this you can see it, how the rollers are in touch. The contact between the roller and outer race is line contact. That's why it comes under the category of higher pairs. So in this class we studied in more detail the classification of kinematic pair based on the nature of contact, that is higher contact, higher pairs and lower pairs with in detail animated examples. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.